Alright guys, great. So following up from the last video, let's go ahead and evaluate some limits using just a method of direct substitution. So for the first problem, we're going to go ahead and take the limit as x approaches 8 of the function x over 4. And in direct substitution, this is pretty simple. All we want to do is substitute 8 for x. So what we will get here is 8 over 4. And 8 over 4, that's just going to equal 2. So the limit of this function as x approaches 8 is just going to be 2. So let's try one that is slightly more complicated, but still follow the same general guidelines. So let's do the limit as x approaches 2 of f of x. And that function is going to equal 9x plus 1. So here we see a polynomial, 9x plus 1, and we're going to do the same thing. Even though it's written slightly different, I'm just going to throw a couple of different styles out just so you can see that you're pretty much going to do the exact same thing. So you're just going to substitute 2 for x, because we're trying to see what the value as x, as it gets closer and closer and closer to 2, what this function value is going to be. So what this will equal is 9 times 2 plus 1, and we see that the value of this function as a limit of x approaches 2 is just going to be 19. All right, so let's try another one that is going to be slightly more complex, or it's going to feel like it's slightly more complex, but it follows the same general format for direct substitution. So we're going to take the limit as x approaches 2 of the square root of 4x plus 8. Now, a lot of these you got to actually be careful when you're evaluating square roots, because if you get a negative or equals 0, then we'll find out a lot of times it's just not going to exist. But here, if we go ahead and do direct substitution is pretty much the path of least resistance. You can go ahead and get your value, see if it exists or not. If it doesn't, then you'll have to try the other methods to see if the limit exists using these other methods. And if it does, then you will go that route. So it's not always that if the value doesn't exist off direct substitution that it doesn't exist overall, but usually direct substitution is just the easiest first line of attack that you want to do when you're solving these problems. So here we see we got the limit, and if we do 4 times 2 plus 8, the square root of that, we get the square root of 16. And the square root of 16 is just 4. So the limit of this function as x approaches 2 is going to be 4. Now, let's try another one. And I know these are real simple, but the more practice that we get on the basis, the easier that the other methods get. So now let's go ahead and try the limit as x approaches 3 for x squared minus 9 over x plus 1. And again, direct substitution, we're going to substitute 3 for x, and we're going to do it for the numerator and the denominator. And we're going to go ahead and evaluate and see what we get. So here we get 3 squared minus 9, which I know you guys are watching, you guys like, I can easily calculate this in my head, but I usually like to write it out just so we can get a full view of what's going on. So we get 9 minus 9 over 3 plus 1, which equals 0 over 4. Now, you don't have 0 in the denominator, but you have it in the numerator. So this limit as x approaches 3 is 0. So this limit exists, and the value of this limit as x approaches 3 is going to be 0. So now, this one's going to be very important. So we're going to try a direct substitution for a fraction with an exponent in it. So let's see, if we do the limit as x approaches 4 of f of x, and it equals 1 over x minus 4 squared. Now, when we evaluate the limit, what we're going to see is when we plug in 4 here, 4 minus 4 equals 0. Of course, you can't square 0, and we have 0 in the denominator. That's going to say that the limit doesn't exist. That's what our first instinct is going to tell you. So, but even though we know that x can't equal 4 for this limit, if we draw a graph here, so x, y, and let's say 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So let's see what's happening at x equals 4. So what we can see is we're getting a vertical asymptote. If you graph this function, we're getting a vertical asymptote. And as values are approaching 4 from both the left and right, is basically going to infinity. So using the method of direct substitution, we find out that this limit, f of x, is going to equal infinity. So here we know that the limit does not exist because it's hitting every value of y for infinity. So there is no direct limit for this function here. So we'll just write limit does not exist. Now, a lot of times you want to make sure that when you are doing these problems that even though they seem very simple, some of these here is like, okay, direct substitution, you plug in the 2, you get out a value, so it exists. Another one, if it exists, doing a direct substitution, good. But sometimes if it doesn't, you may want to try another method or just simply drawing out the graph to get a visual representation of what's going on. And then a lot of times you can say, okay, I can say for certain that this limit doesn't exist because I can see a vertical asymptote and I can see that this function or this graph is not going to hit that line. So I don't need to try any other method. And lastly, a good thing to note is that you can use substitution on limits towards one point whenever that function is continuous at that point. And that's pretty much the definition of continuity. So if you have a continuous functions, then the direct substitution is going to work at that point where the limit exists. So I hope you enjoyed this video. I'll try and see if I can find any more interesting limit problems to do. I didn't want to actually make this too complex. I wanted it just to be simple and straightforward. So let me know what you thought in the comments below if you found this video helpful. And we're going to go ahead and get right into the next method, which is factoring the equation and for evaluating limits.